Welcome everybody to this heat transfer class, our first day of class, and we still cannot do it in person, but I still believe we can accomplish great things. My name is Patricio Mendez. I'll be your instructor for the class. Your lead TA is Bilal Baradia, who's also here listening to the lecture, and you have both of our contacts in the class material. Before I go further, I'll I'll tell you we will be recording the lectures, and then I'll be posting them. I intend to post them within a week that we have the lecture on eClass, so you have it. And okay, oops. Something I would like to suggest is that you turn off, you mute yourselves, and you turn off your cameras, because otherwise everything's going to be recorded. And I have the chat window open, and if you have questions or comments, that would be fantastic to hear. I'm paying a lot of attention to that, and last semester that worked very well, and that gives me a chance to react to you guys, because I'm seeing the screen, but I'm not seeing you, and I think it's a terrible loss. But we'll make the best we can from this, and maybe it might actually be quite okay. So if there's a problem with sound or anything else, just send me a message through the chat, and I'll react to that. If you like something, or if something is really off, you let me know. Let's see, let's make sure that everything's working well. Okay, everything seems to be working well. All right, so we can start. What I'm going to do is to tell you a little bit about myself, then to tell you about the structure of the class that we'll have, and we'll start talking shop right today, very quickly. So something about me. The charming accent is from Argentina. I'm a mechanical engineer, which is interesting because some of you are chemical, some of you are materials engineers, even petroleum engineers, and I'm mechanical. But in the end, the science, heat transfer is a matter of laws of nature, and that is universal. I did research on wind turbines when nobody knew what wind turbines were. Interesting, in the 80s. And that's me up here in a wind turbine, and I'm afraid of heights. So it's quite an interesting experience. And then I saw the light, and I'm doing much of oil and gas now, although oil and gas is not the best bet for long-term employment right now. So I also worked in a steel making company, Tenaris, where we designed, well, I designed this weird contraption here to measure friction. And that's how I got involved with materials, with steels, using these design skills I acquired in my education. From there, I had the great fortune of fulfilling a dream that was to study abroad and to go deep into a field of engineering. And I did my master's and my PhD at MIT in Boston. Was fantastic. I did a postdoc there too. And I had the fortune when I was there of having a startup in the early 90s. All the startups were about internet. And ours is the only startup I know that was not about internet, but was about manufacturing, in which we invented a machine. And here you have a photo of the machine we invented. This is an image from one of our 9 patents. And this machine made parts for the Ford Focus, this part that you get to see here. And because the Ford Focus was a global car, every Ford Focus in the world of this vintage has this part made in our machine. Sure enough, I not too long ago here in Canada, I saw a Ford Focus of more or less 2000 vintage. Opened the hood, and guess what? Our part was there. That was quite amazing. So, for being a professor, I can say that once I did one useful thing. It doesn't happen all the time, but that's a good thing. Now, an interesting thing is that we were working on this technology that was good for what today is called additive manufacturing. At the time, nobody cared. Let me show you what thing we did. We were doing additive manufacturing of metals. And this is a video from our lab, from when we were doing our masters and then our startup. And if you see here down the dates of the publications and the dates of the patents is pre-2000, and it's so long ago that the patents are expired. You can go and take advantage of them now. Look at this. Now people are doing things that look so much like what we were doing. Isn't that interesting? Actually, ours looked a lot better than these. It's an interesting thing. So I finished my PhD. I was an entrepreneur. I was a consultant, but my heart was in teaching and being with and living in a world of idea, being with the students and being a mentor. Those things are important to me. So I stopped seeing the chat here. Here we go. Those things are important to me, and I became a professor. I was a professor for years in Colorado School of Mines. That is one of the a very well regarded university in the U.S. for metallurgy and for welding. That is what eventually brought me here to Canada. And when I was there, I was in charge also of a foundry. And this is an image of the photo from the lab I run that had like big furnaces. We had so much fun there. Also, something I like very much of is riding my bicycle, and Colorado was fantastic for that. This is me at the top of Mount Evans. That's a 14er. And it's not for everybody. It took about 6 hours only uphill to get up there. And then when I was a professor in Colorado, happily riding my bicycle, I got a call to come and start a welding research lab from scratch. And welding has lots of to do with heat transfer. That's also why I'm teaching this heat transfer class. And I decided to leave everything behind and come back to Canada. And this is the new me now. This was actually almost exactly a year ago. We had minus 36 before pandemic. I love bicycle commuting, especially in the winter. It's something I like and I enjoy. I have a good bike for that. And so far my record is minus 36 C. For those of you in materials, minus 36 C might be below the transition temperature of the steel. So I'm afraid that if I fall, the bicycle might shatter. And I came to create this research center here at U of A. That is a Canadian Center for Welding and Joining. And it's a very international place. It's a very diverse place. And it's a place that makes me so happy to have come. It's such a great fortune that I had in my life. And now I don't mind the winter. Yes, I like the beach and the sun, but the winter is okay, and everything else I have gained is so much more than I thought could be. Our lab is well supported by many companies, and one of the good things for the students involved in our lab, from the PhD students to the undergraduates, is amazing job opportunities. And I'm very proud of that, because that means industry sees value in the things we're doing, including the teaching of this heat transfer class. We have equipment to measure pretty much everything. We have a thermal camera that is not like your drywall inspector camera. This is a $150,000 thermal camera that you can aim to things as hot as a welding arc and it will not fry. And for those of you in MADI, we have everything from instrumented Sharpie, dilatometers, hardness mappers, many interesting things. We have one of the best well set up labs for welding in the world, welding and metallurgy. If any of you is interested in our lab or in research in general, this is the time to start thinking. You're in third year, you can engage in a Dean's Research Award, in which the requirements is to have a relatively high GPA. And I've seen cases in which if you don't cut the 3.2 exactly, they're willing to accommodate. The time requirement is 3 or 4 hours a week. And you get paid approximately or exactly $500 per term. I just got a note from the dean that DRA's Dean Research Award will be available this year. They all will be, of course, off-site. But if you're interested, I'll be happy to discuss. Here's a possible project that is about computer modeling of welding and additive manufacturing. We have amazing software in the lab, very expensive. We are learning to use it, and would be fantastic to have you on board to help us. And we expect around September to have a big metal additive manufacturing machine that is being set up right now to be sent to Canada and being installed in our lab. A machine that can make things like small ship propellers, right? So if you're curious about getting deeper into technology, not necessarily for an academic career, but just as an engineer, I recommend you consider a DRA opportunity, not just in our lab, with any other professor. I think it's a great opportunity for students. So that's about me, and that's about the lab. And so let's talk a bit about the class. Okay. So the e-class system is already active. I already uploaded this document, and I have already uploaded the notes for the first week of class, and actually are the notes for all the rest of the semester. Although I might be improving them as we discuss and I see ways of making things better. And so about this class, why I asked to teach this class. This is, not everybody wants to teach this class. It's long and it's difficult, and sometimes students are happier than other times. But this class puts together everything you have learned. You have learned math, and you don't know what to do with the math, and you have learned physics. And what was the point of all that physics? And now in this class, we're going to put together that math, those physics, and make predictions about things that are the basic governing laws of the world, right? About how heat is managed, comes in and comes out. Sounds so easy, but in the end is the difference between effective machinery. Things like, for example, the maximum speed of a computer. You know what the limit is? It's heat transfer. It's not electronics. And those of you who are into serious gaming, you know what I'm talking about, because you can overclock your computer if you can cool it faster. We're going to learn all about that in this class, right? Like why babies are more sensitive to cold than adults. It's all about the things you're gonna learn in this class. Why do we eat 2,000 calories? We need 2,000 calories a day to survive. Heat transfer. It's quite amazing. So if anything, I hope I can convey to you this sense of amazement, of exhilaration, of adventure, and also this sense of control, that now you can think things and make them happen because you understood how the thermal energy plays a role in life. So we're going to have our lectures Monday, Wednesday, and Friday at this time. We're going to have seminars on Mondays, but not today, starting next week, and they will be in charge of our TA, Bilal, and everything we'll do through the same Zoom link. So everything about this class, you're going to log in here. This is where we're going to have every lecture, every seminar. If we have reviews, the reviews, office hours, right? Now, because we're in quarantine and I don't get to see you, you don't get to see me, and teaching is so different, so much more different than used to be. The evaluation, something that you care quite a bit, is going to be very different than previous classes. We are going to distribute the grading in many small parts. Instead of having a big final, we'll have no final at all. We're gonna split it into 60% in small quizzes and 40% of the grade in at-home assignments. The 4 quizzes are quizzes that cover about half the content of each of the previous quizzes in this class. And the time, I put 2 hours here, it's actually an hour 50, and is double the time of a normal quiz. But what I learned from previous terms is that it gives a lot of anxiety to the students to be in front of the computer and having to answer something that is so rigidly defined. So there are many quizzes of small weight each with lots of time. 40% of the grade will be by work at home, and there are 2 assignments, and you're going to upload them to eClass, and the links are already active. The first assignment is a traditional assignment. We have not posted that assignment yet, but will come up soon. That will cover much of the material up to the first class, up to the time of the first assignment. This assignment, you write as you do. You're going to scan it properly because it has to be readable, and we'll go over that. The second assignment, has much of the same features, but this one will be an assignment more at a professional level. That will be typewritten, not just scanned. No part of these will be scanned. You'll typewrite it, will be fewer exercises. This assignment 2 is already posted, and you'll submit it. It's more like a technical report than just a kid's assignment, and showing the transition, how in this class you go from very basic type of classes into an engineering type of behavior. So this will give us a chance to to test things and exams, test things by working at home, well distributed. About the textbook, I very, very, very much recommend you get Introduction to Heat Transfer by Bergman, Lavin, Increpra, and DeWitt. And I suggest you get the 6th edition. There are newer editions, but much of the class material I prepared is based on the 6th edition. So sometimes I will say, this is this particular equation. and that it corresponds to the equation of the 6th edition. Newer editions, the laws of nature are the same regardless what edition it is and regardless what editor, what author you have, but it will be convenient. You can get the book and in paper form. I have it and I love it. You can get it digital, and that's perfectly fine. And you can shop for it online and find it. There's another book that might be convenient. That is a book that a professor in our own department, Professor Robert Hayes, has written, and here you have a link. So that's a good thing. About the format of lectures, the lectures I'm going to deal with both theory and some examples. And in the seminars, we'll work out on examples. And what I hope to do, which I think we can do now with in Zoom, is that for the seminars, have you practice the problems and have the TA help you to see when you get stuck in what point, so you're best prepared when the exam comes. I have uploaded for your practice the answer key of every exam I gave on this class. And those answers are worked out by me or the TAs. It's kind of the official answers. And that will be good practice. The unfortunate thing is that these exams now are going to be a little bit different. I'm making a very big effort that the exams are exams in which we don't have a carryover error. So if you put this is the answer, it doesn't, a wrong answer in question 1 doesn't ruin a good thought in question 2 that is based on a faulty assumption. So that I think that's going to work well. We did it in the class last semester and worked out quite well. So a question that comes often is about missing quizzes. So if you anticipate a conflict of schedule with any of the quizzes that are already posted, please let me know. Let me know within 2 weeks. Let me know and we'll discuss. If after this you miss a quiz, there is still a way of fixing the problem, but you need to talk with the associate chair for undergraduate, Professor Tony Young, right? And so all quizzes, you need to be there, is mandatory, and all assignments need to be turned in. So anybody has a question about the, if anybody has a question about the class, please let me know through the chat. Okay.